Good morning and good afternoon, wherever you're joining us from today for this webinar on healthy harvests in a changing climate. And I'm delighted to welcome you to this webinar where we have a great program on the topic of adapting smallholder agriculture to the effects of climate change with particular focus on plant health. My name is Paul Egan and I'm an associate professor at the Swedish University of Agricultural Sciences, SLU. And today's webinar is held in conjunction with the IITA and the CGIAR program. And we will hear more about that program later on and also about SLU's contribution to plant health. To note that today's webinar is being recorded and it will be made available at a later date. So if you miss some parts, or if your colleagues would wish to recap on how we got along today, you're more than welcome to revisit this video in due course. I will introduce the program to you just quite shortly, and we will have a welcome message from Ylva Hilber from SLU and David Chikoye from IITA. First, I wanted to introduce a couple of the aims to you as a whole. So this dialogue that we're having today is bringing together really a huge diversity of different stakeholders. We've received close to 230 registrations for the event, and the diversity is quite impressive, ranging from meteorologists to farmers themselves, to farming organizations, extension services, private sector businesses, and then political links like to the UN, FAO, and World Food Programme. We're also seeing attendance here today. And the main aim is to discuss how nature-based solutions can help climate-proof smallholder plant health. So we have a particular focus in low and middle income countries. Today's event also serves as a contribution to two upcoming events, which is Stockholm Plus 50, which is harnessing and celebrating 50 years ago, an important milestone meeting that served to go on and influence the formation of UNEP, the United Nations Environmental Programme. But today also is helping us mark the UN International Day of Plant Health, which is coming up on the 12th of May. And we're delighted to see that the UN has newly designated this day on an annual basis to celebrate and mark the importance of plant health. The speakers that we have, we're really delighted to have such a big diversity, because this topic is so broad and so deep and connects to many different stakeholders and different needs to get IPM, integrated pest management, working in a climate smart way, that we really do need to bring in this diversity of speakers. So we're really glad to have that on the program. I'll hand you in a minute to Ylva Hilber and David Chikoye to give welcoming messages, but otherwise we will move then to the scientific program and look at the science about how we can get climate smart integrated pest management working. We're looking at many of the different nature-based solutions. Then we will take a moment to look at your answers to some questions that we're going to pose. So we want your opinion today, and we have a Padlet board set up to get input and feedback from you. So please, when we share these details, I would like you to go on and share your opinion with us on several important issues. Following that, we will move on to looking at this topic from a practitioner angle. And we're delighted to have three speakers representing different facets, different stakeholder interests to give us their perspective on these topics and connect to certain issues such as the fall armyworm spread and desert locusts, and looking at early warning responses that are needed to tackle those issues. We'll finish then with a panelist discussion and questions. And so I would invite you in the chat to, or the question Q&A function, which you can see above in Zoom. I would invite you to send your questions in there to the panelists, to the speakers. And the speakers will write back in the chat, apart from our panelists today, and we will be able to take some of your questions once we initiate the panelist discussion. I will hand the floor now to Ylva, who is the Pro Vice Chancellor for International Relations at SLU. Ylva, you're welcome, and the floor is yours.
Thank you very much, Paul. It's my great pleasure and privilege to welcome you all on behalf of SLU to this webinar and this seminar on such an important topic as plant health or healthy harvest related to climate change and the challenges that entails. Plant protection is a key area of research and focus area of SLU. We have more than 200 researchers working in that field, and they're all gathered in the SLU Plant Protection Network, and you'll find the link to that network in this slide. And they work on different aspects of plant protection and plant health. And I'd just like today to highlight some examples that are relevant for the scope of the meeting today and related to different approaches to plant health. So just the first one here, we have a number of groups working on topics related to host plant resistance and tolerance. And a couple of examples here are linking to epigenetic variations influencing viral resistance and yield in cassava farmers, for instance, farmers' fields, sorry, but also plant resistance inducers, the next set of questions for future sustainable agriculture. We have several projects related to biopesticides, and they're focusing on different aspects. So at the agroecosystem level, but also specifically on different types of biologicals and the identifying hurdles through different approaches through stakeholder analysis. Next slide, please. Another important approach regarding plant health is, of course, the whole habitat, to look at habitat manipulation and looking at resilient cultivation systems, for instance, in corn production in East Africa is an important new project. We are working on projects in coffee, black coffee twig borer in Ugandan, small coffee holder gardens, and how we can work through the push-pull technology. We'll hear more from the push-pull perspective from Samira later on, I believe. And biological control, we know there is a strong group at IITA working on biocontrol as well. And here we're looking at how we can identify, explore, and preserve the diversity of utilitarian insects in tomato cultivation. And then semiochemicals, the odors emitted by either insects or plants for communication, and how that can be used to detect, in this case, an invasive species, the spotted wing Drosophila in continental sub-Saharan Africa. So those were a few examples of the research projects that are going on. If I can have the next slide, please. But we also work in partnerships with a number of different activities, workshops, training courses, symposia, etc. And here are a few highlights related, for instance, genomic analysis of potato to control late blight in collaboration with ARC in South Africa. We're working on biologicals and a whole set of courses in bioinformatics that are conducted in collaboration with IITA and others. So a multitude of activities related to plant health in different ways. And the funding for these activities come from several sources, including the Swedish Research Council, SIDA, EU, UNFAO, STINT, and others. So lots of partnerships going on. And I think today's meeting is an opportunity to connect and to continue to build these important partnerships within this key area of research. Thank you very much. And I'll hand over to you, Paul.
Thank you so much, Ilva, for highlighting the important work going on from SLU in conjunction with many partners, both in Africa and other low and middle income countries around the world. Next, I would like to invite David Chikoye from IITA to give his welcome and to introduce David. He's the Director of Plant Health Management and also at the Southern Africa Hub Director based in Zambia himself. David, you're very welcome. Yeah, please, the floor is yours.
Thank you, Paul. Good afternoon, everyone. It's really my pleasure to be here to give this small brief on IIT's work on plant health management. In IITA, we have a multidisciplinary team of plant health scientists who are actually working in many African countries, as you can see from the map. I want to say also that this is the biggest plant health management team within the 1CG consortium. As IITA, we work on a broad number of crops, as well as many cropping systems. Can I have the next slide, please? Yes, even though we work on many crops, our focus is on the IITA mandate crops of maize, banana, cassava, yam, cowpea, and soybean. Within these crops, we have identified about 20 priority pests and diseases. But then within these pests and diseases, there is a lot of effort, which is actually now going towards the control of 4 armyworms, aflatoxins, Fusarium wilt in bananas, cassava brown streak disease, the Maruca pod borers, as well as many parasitic weeds. Next slide, please. Now, in terms of the priority intervention areas, firstly, for some of these emerging pests, we identify and characterize them. We assess the impacts on food security as well as livelihoods. If the pests are of significant impact, the initial intervention is to try to contain them so that they do not spread to larger geographical areas where they can cause more damage. Then, to prevent further crop damage, we develop, validate, and deploy ecologically friendly as well as integrated pest management innovations. Usually these innovations are anchored around the use of resistant crop varieties, biological control, the use of agroecological approaches, and where justified, we can promote the use of environmentally friendly pesticides. About 3 years ago, to mark the 50th year of IITA existence, we actually published a monograph which highlights some of the achievements we have made in plant health. And I encourage all of you to look at this manuscript. Next slide, please. Now, we also facilitate scaling of plant health innovations using scaling readiness approaches. We strengthen the capacity of scaling partners. We also ensure gender and social inclusion. We work with a broad number of partners, which includes demand partners. These are usually government entities who help us to identify key priorities. But then we work a lot with innovation partners who help us to co-create plant health innovations. Usually here we work with advanced research institutions. Then we work with scaling partners, usually the private sector as well as extension, to stimulate demand and deploy innovations. Now, in addition to our network of laboratories, which are scattered in the countries where we work, we have a few research assets I wanted to highlight. We have the germplasm health unit, which ensures safe germplasm exchange. As you know that we support a lot of our partners in terms of access to germplasm. We have the Insect Biodiversity Center in Cotonou, which facilitates pest identification. We have the Drabo Forest Reserve, which we use for taxonomic services. And finally, we have the Biorisk Management Facility, which focuses on climate-related biorisks in West Africa. Last slide, please. Last slide. All right, so you have heard this brief. What I want to do is extend my invitation to all of you to partner with us as we combat diseases. In the picture, you can see our team, and note here that some of the membership extends beyond Africa. Thank you for listening.
Thank you very much, David, and also Ilva for your welcoming messages here and giving some background on SLU and IITA's and other partners' ongoing collaboration in these areas. Next, I would like to invite again your input, and you can do that in 3 different ways. Firstly, in the Q&A function, as mentioned, any of the speakers, once we get going in our scientific program and practitioner program, any questions to the speakers, you can put in the Q&A directly, and those speakers will either get back within the Q&A with answers, or we will take it up in the panelist discussion. Secondly, on Padlet, which the link has been shared in the chat for you, we invite you to click in there and when you have the opportunity to answer these questions, which we would like to involve within the synthesis summary of the webinar today. So as mentioned, we're bringing together really a diversity of different stakeholders and different interest groups amongst our participants here today. So we really want to hear from you, and we want to hear what your views are across several of these questions in terms of how can we get climate smart integrated pest management working into the future for smallholder farmers. And thirdly, engage with us on social media. We're happy to see you on there and to share anything that you might like on there. Without further ado, I think we will jump into some insight into what brought this webinar together, which is a report that has been generated in 2001, so not so long ago, on harnessing nature-based solutions for smallholder plant health in a changing climate. And I'm very thankful for the authors that were involved in formulating the ideas and the process around this concept of climate smart IPM, integrated pest management. And we've put together a resource package, which includes the report, policy brief, and a video. So I encourage you to also check out these resources, which are largely based on the talks which you will hear today. I will share some of the key messages for you from the report. The speakers will elaborate many of these topics today. So really, we just take a quick look that we're considering 5 main practices when we talk about nature-based solutions for plant health, and that's the use of semiochemicals, habitat manipulation, biopesticides, resistant and tolerant varieties, and biological control. And this concept of nature-based solutions has largely had a coexistence away from an agricultural context. So these type of dialogues usually don't reference agriculture or these techniques. So it was a first exercise just to consider, how does this paradigm of nature-based solutions apply to plant health? Secondly, from the climate change angle, we considered how climate change can threaten the function of all of these sustainable solutions for plant health, and what we can do to counter that and to make these nature-based solutions part of the solution. for adaptation. And in doing this, in considering the science behind all of these 5 practices, we come with a proposal for this concept of climate smart IPM. So what does it mean to make IPM climate smart? That's a tough question, and I think collectively we will tackle that together amongst all the speakers here today. Another area that we connected to was One Health. And in context of One Health, plant health is somewhat of a neglected concept. When we talk about One Health and the integration of environmental, human, and animal health, there's some obvious connections in which IPM connects to One Health, but these are poorly elaborated. So we have considered how implementing IPM in these climate smart ways can both increase food security and food safety. And we're grateful to hear from our first speaker in the scientific program, particularly on food safety, who I'll introduce pretty shortly now. But the other speakers that we will hear from will also elaborate ways in which we can implement, in a practical sense, climate smart IPM. So that means getting things like advisory services really working, that have well-informed climate information, both in immediate terms, but also long-term, more long-term forecasts as part of horizon scanning. Policy streamlining, we'll hear about some issues about how policy can help remove the blocks, I should say, towards getting things like biopesticides working as an alternative to synthesized pesticides. And co-creation and sharing of knowledge with and amongst smallholder farmers themselves, which is a critical aspect. We can't do this alone, and scientists they're compelled to collaborate and co-create knowledge. It's not just a practice that scientists do themselves. So as I said, I'm delighted to welcome all of our speakers, and we will start with Titaleya, who is from IITA, and her expertise is in plant pathology, and she has worked on the AFLASAFE project. And her talk is on using AFLASAFE as a climate smart technology for food safety and One Health. With that, I would like to welcome you, Titaleya, and the floor is yours.
Thank you very much, Paul, for that kind introduction, and thank you for the opportunity to talk about AFLASAFE as it contributes to plant health in the context of IPM, as you spoke, and in the context of One Health and climate change. As we go to the next slide, I'd like to share a true story about what can happen as we begin to experience severe changes in climate. From 2016 to 2018, there was a drought in Kenya, and from Susan's personal story, we see how climate change can affect joint health in a shared environment. Due to aflatoxicosis caused by dietary exposure to aflatoxins in maize that herself and her family had consumed, she became a widow because her husband died. She lost her son and her grandson, and can hardly recover from the poisoning that resulted from aflatoxins in their diet. They ate contaminated maize. As we see on the right photo, we see it's not easy to discern which grains are contaminated and which are not, because aflatoxin contamination is not visible and can occur in the absence of visible fungal infection. In the next slide, I talk about aflatoxins, which are naturally occurring chemicals, and they're produced by ubiquitous fungi. These fungi are always associated with the crops on the field, and toxin accumulation is predominant in regions that are warm, and these are usually between 40 degrees north and 40 degrees south of the equator, where there's perennial exposure, risk of exposure to aflatoxins. And several staple foods consumed in this region are at risk of aflatoxin contamination, whether they are nuts or spices or grains or tree crops, a varied mix of foods. In the next slide, we see that aflatoxins result in negative outcomes to joint health. But integrated food management systems, including the use of AflaSafe, if you just click one more time, can result in positive outcomes. So these would include improvements to plant health that would lead to subsequent healthy diets for humans and animals. There will be reduced need for treatment with pesticides to the crops. There will be less likelihood of misuse of antibiotics on animals that are ill or immunosuppressed from aflatoxin contamination. And as these are fed to humans, it will lead to better health outcomes, and humans will be able to provide better health care to both plants and animals. So AflaSafe is able to provide this positive benefit in the One Health concept. And in the next slide, I tell you a bit about what AflaSafe is. It's an innovative nature-based solution to aflatoxins. It's a bioprotectant comprising country-specific strains that are well adapted and widely distributed. So these strains in AflaSafe are aspergillus flavors, and they do not have the ability to produce aflatoxins. From several studies you see on the chart on the right, we've seen that AflaSafe continues to show efficacy in the control of aflatoxins. Using AflaSafe results in little to no aflatoxin contamination. And this particular chart is showing data from over 1,500 fields. So AflaSafe is a climate smart, nature-based solution. Next slide, please. That has been used to treat several farms and resulted in the production of over 1 million tons of aflatoxin-safe crops, resulting in safer food being available and improved outcomes. Next slide, please. We have several documented outcomes of AflaSafe's contribution to joint health. These include improvements to livestock health and productivity, production of safe grains for humans and animals, demonstrated in a 10-year study that shows AflaSafe continues to result in low levels of aflatoxins in grains, and evidence that shows that AflaSafe does not distort the ecological balance. Results from, next slide please, results from safety studies, from ecotoxicological studies show that AflaSafe has no adverse effects. It confirms its safety to humans, animals, and the environment. Next slide, please. As part of our contributions to One Health, we make the knowledge of aflatoxin control using AflaSafe available to trainers, to farmers, to people handling crops from the food to table, paying attention to gender dynamics and ensuring that this information dissemination reaches all demographics. In the next few slides, we'll be looking about how climate change can influence One Health. A typical scenario would be that if the smallholder farmer will work for extended hours with trained animals for field activities. But with increased temperatures, there will be stress to humans and animals. This would result in fatigue, leading to reduced care for livestock. This would lead to reduced resistance to diseases, requiring more treatment with antibiotic use. This would leave residues in the food for humans and aflatoxins also in the diets. And these, when humans feed on them, would lead to poor health outcomes and an inability to contribute productively. And this results in a continued cycle. Next slide, please. Next slide, please. With humans and the environment, just please keep clicking till we go to the next slide. With humans and the environment, there's increased temperatures would lead to high plant stresses with increase in pest and pathogen presence. And this would cause plants to contribute to negative health outcomes in humans and in animals. And if we could just go to 2 slides after that, we could see that aflatoxins in animals and in the health of the environment would result in predominance of toxigenic strains. So when there's increased temperatures, environmental health would be affected. There will be more predominance of toxigenic stress to strains because they cope better in harsh environments. There'll be other biotic stresses that predispose the crops to aflatoxin contamination. And when this becomes sources of diet to humans and animals, then there'll be growth deficits, liver cancers, and other health problems. In the next slide, we see AflaSafe as a nature-based solution. The next slide, please. After this one. As a nature-based solution, AflaSafe contributes to supporting a healthy balance of non-toxin producing strains. One slide before this. This enables plants to cope well and become a healthy source of food to both humans and animals. And in the next slide, with a photo of the farmers, we see where they have spoken specifically about how AflaSafe has contributed to improvements in their grain quality, in benefits to livestock, with one farmer specifically mentioning reduced mortality of his birds and a reduced need for antibiotics to be administered to his birds when they're fed with AflaSafe treated grains. We've had significant support, the last slide please, we've had significant support from national, international, and development partners, and are grateful to them and acknowledge them. And we couldn't have done this without their support. So thank you very much for your kind attention. I look forward to comments and questions that follow. Thank you.
Thank you so much, Tadalea. And just to remind participants that you can ask questions within the Q&A function, which you can find in Zoom. And Tadalea will come back to us for the panelist discussion so we could raise whatever questions that you might contribute there. Thank you once again, Tadalea. And we can move on to the next speaker, which is Ghislaine Tepeyoto from IITA, and Ghislaine will talk to us partly based on IICCRA's work, the new initiative from CGIAR, and bringing in this important topic of climate smart monitoring and deploying different management based on One Health outcomes too. So very much welcome, Ghislaine, and yeah, thank you.
So really quite exciting to see colleagues joining from all corners across the globe. And I think this is really a great opportunity to foster innovative partnerships, because this is extremely important in terms of improving synergies and collaboration to tackle pests and diseases issues locally and regionally as well. So from the very beginning, I would like to really recognize the importance and relevance of the funding support from the World Bank in 6 African countries, Ghana, Mali, and Senegal in West Africa, and Ethiopia, Kenya, and Zambia in East Africa, to accelerate impacts of CGIAR climate research for Africa. So the beauty of this program in Ghana, for instance, where we are leading the project, is the fact that one of the focus areas of the program is dealing with climate-driven pests and diseases in the context of the One Health approach that Titilayo presented very well. If you move to the next slide, really the AICCRA project was providing the ground to really do an assessment and carry out prioritization work for technologies that are climate smart. And in the same time, using climate, gender, and social inclusion and One Health lenses to really define the priority technologies that are suitable for the different interventions regions in the country in Ghana. So during our preliminary work in terms of assessing the needs of farming communities, it was frequently reported that pest and diseases issues are becoming really critical in the environment. And there was a statement during the last big event of the AICCRA project in Ghana from a lady, a woman leader of one group that mentioned pest and diseases issues becoming very critical. So this is really something that we are taking very seriously in terms of the impact of changing climates on the invasive alien species. And these new problems are adding to the existing and the resilient communities of pests that already are present in the environment, which makes the situation even much more complex. If you move to the next slide, there is really a consensus that climate change is really posing a significant problem in terms of its impacts in terms of increasing yield losses, increasing establishment rates of invasive alien species, disruption of ecosystem services, and the increasing evidence that rising temperatures and CO2 are really disrupting the efficiency of pheromone lures that are commonly used for pest monitoring and surveillance. So this is really causing us to lose 40% of food crop in our system. And if you move to the next slide, you will see in terms of socio-economic consequences, what it means, the impact of invasive alien species and how it is affecting country GDP. Next slide, please. So we are really looking at the issues using climate lens, like I mentioned, but also making sure that any technologies, any innovations that we are deploying are really One Health sensitive, as rightly pointed out Titilayo just a minute ago. So I want to really emphasize the need of moving towards the next version of the One Health concept. And this was really strongly advocated for in the reports that we have put together last year, and what Paul mentioned in the very beginning, that the One Health concept should not limit to the integration and interactions between human and animal health in terms of addressing zoonotic diseases. But obviously, there is really an increasing need to consider other elements because of increasing concerns about antimicrobial resistance and the fact that pest residues issues in food crops is really becoming really critical. So we think strongly that it is worth considering plant, soil, and water elements as some of the drivers that can worsen human and animal health, and also can lead to significant negative impact on our shared environment. So we are working to provide evidence to show the interconnection and the relevance of considering this element, that they should become really prominent when we are addressing One Health issues. If you move to the next slide.
1 minute, Ghislaine.
All right. We are really looking at climate smart IPM innovations to consider pre-building blocks. First of all, we should continue about surveillance and monitoring efforts. We should keep providing decision-making support products. And next month, we are organizing in Ghana a big event in the framework of AICCRA to strengthen national partners' capacity in terms of co-constructing and deploying fully functional early warning and rapid response system. Next. The next slide shows some of the products that we are providing, and they are available publicly and accessible to support decision. I think that's the last thing, and I will finish by thanking everyone for listening and ready to take any comment or question. Thank you for listening.
Thank you so much, Ghislaine. And just to encourage you again to send some questions in on the Q&A. I think the speakers are waiting to address anything that you would like to raise. And also to note, again, the Padlet link you can find in the chat. So please keep your responses coming in there. I'd like to move on and introduce our next speaker, Emily Popenberg-Martin from the University of Hanover. Very welcome, Emily. And today we will hear from you on expanding push-pull systems in East Africa, one of the most successful examples of sustainable pest control and that are giving viable alternatives to smallholder farmers. And great to hear about the Upscale project. Welcome, Emily.
Thank you very much, Paul, and thank you for the opportunity to be here today. It's an honor also to meet and hear these different speakers from my side. So today I'm going to briefly tell you a little bit about the Upscale project, which is currently going on in East Africa, where essentially what we are trying to do is upscale and expand push-pull technology. So I'll tell you a few words about the push-pull technology to start with, but just very briefly, I'm sure Samira, who's coming right after me, you will also say something about this. Next slide, please. So the push-pull technology, it's been briefly mentioned also by Ilva before. It's a system that was developed by the IITA in Kenya, where the idea is to intercrop maize with companion plants, some of which have a push effect in that they have chemical repellents by which they push pest insects outside of the maize crop. And around the crops, the plots of maize are grasses such as brachiaria grasses or napier grasses, which actually have an action of pulling pests out of the maize crop, and they are trap plants on which the pests cannot reproduce very well. So hence the name push-pull system, which is very, very successful. If you look at the next slide, please. It shows very strong yield increases when applied in smallholder farms in East Africa and also elsewhere. It's a fairly straightforward system to implement. And as you see, these yield gains can be very extreme, especially in areas with a lot of pest pressure, particularly stem borers in maize, but it's also effective against the fall armyworm. And there's really a whole package of benefits to this technology. It's quite holistic, and not only the yields are increased, but also it is de facto organic as such. It improves the soil fertility because the intercrop that's planted between the rows of maize, which is called usually Desmodium, different species of Desmodium is a legume. And so it fixates nitrogen in the soil, thereby improving fertility. It leads to water preservation in the soil. It also controls the very noxious striga weeds in these plots, thereby really broadly improving livelihoods, food security, also gender empowerment, because there are some impacts on task distribution, particularly for women in these smallholder farms. And also in the context of climate smart technologies, the companion plants that are selected within the push-pull technology plot can be chosen to be climate smart. So there are different generations of the push-pull technology, and most recently, for example, IITA has published the new third generation climate smart push-pull technology, where you see the reference here for Cheruillot in experimental agriculture last year. And this is a selection of species which are actually drought resistant and perform very well under harsh climatic conditions. Next slide, please. So the Upscale project that I'm representing today, we are kind of focusing on broad aspects of the push-pull technology. We're working in 5 countries of East Africa, and the main aims of the project are, on the one hand, to adapt the push-pull technology across different spatial scales and across different crops, and also to catalyze the adoption of the technology and make sure that it is taken up over the long term by smallholder farmers. So these are the challenges that we're trying to address. Next slide, please. And we are pretty much at the beginning of the project. It's really the first phase. So I can't actually give you results from this, but I can tell you what we are trying to do here and hope that it works, and some first insights that we're getting. On the one hand, in terms of adapting the push-pull technology, we are working across broad landscapes with a standardized experiment where we perform agroecological sampling all across the 5 countries. Next slide, please. And using this massive amount of data that is currently being collected now, we want to extract some knowledge and also some tools, among which will be maps and also digital tools, apps, to optimize the implementation of push-pull, to target where it is implemented, figure out suitability maps of where this is a good idea to do it. We will also use these data as well as climate modeling to model the resilience of push-pull under different climate scenarios and also under different configurations of the mixed crops involved in the system. And as a follow-up to that, we want to go more holistic and participatively assess the effects of climate change on these farming systems and how push-pull can help to mitigate these impacts. Next slide, please. So broad overview again, another thing we're focusing on in the project is the question, can we improve and expand the technology to other crops, to other farming systems? And for example, one of these is the climate smart combinations that I mentioned previously, but also with the approach that more flexibility will bring more resilience. We are looking into the options to increase the diversity of the push-pull technology itself by adding legumes into the system, by mixing it with agroforestry, with crop rotation practices, using it for vegetable crops, and so on. Next slide, please. We are also looking at this from a broad transdisciplinary perspective. We're gathering a lot of socioeconomic data, but we're also working directly with communities of stakeholders. We're calling them multi-actor communities, where we try to get insights from the people using these and from the people across the value chain on what barriers are there for adoption of the technology, how can we advocate it, what policy guidelines are necessary, and we're performing widespread dissemination, training of farmers and extension services, and developing digital tools for this. Next slide, please. So just some key questions that I wanted to bring up here particularly is some insights that we're starting to see from, particularly from our transdisciplinary work with the stakeholders, and also from trying to do this field work in the agroecological side. The question is, what is adoption of a nature-based solution or of such a climate-smart technology? For the push-pull technology, we have numbers on adoption, but what do they actually mean? What do they actually represent? How much are farmers really adopting this? And can we monitor and assess disadoption? Because this is also happening. And something that we're seeing a lot is what we're starting to call a project syndrome, in that the adoption of this technology is very much dependent on the existence of a project that supports its adoption financially for the farmers. So how can we make this snowball into something that is a more spontaneous or a more self-sustained adoption? Next slide, please. And of course, related to this, how can we enable the environment for such sustained adoption? How can we catalyze it on the one hand, but also how can we sustain it after the project has ended? Because we are only one project. There are thousands of projects, but we cannot only make this work through projects. So things coming out of our discussions are important factors that might help this. On the one hand is integration within the value chain of the farmers performing push-pull technology. On the other hand, it's creating enabling policies, figuring out certification measures and incentives at the policy levels that will drive this adoption. Another key factor that we see at the moment is training of extension services, not only the ones already out there in the fields advising the farmers, but also people who are currently learning to be extension officers, so that this actually becomes mainstreamed in the curricula of these officers, so in schools, of course. And another major bottleneck that we see is the availability of seeds and plant inputs for this technology. And here, figuring out low-cost systems for availability of seeds will be critical. So with this, next slide, please. I'd like to thank all the partners involved in Upscale, our funder, and all of you for your attention. I welcome any questions. Thank you very much.
Thank you so much, Emily. And I'm picking up some really important keywords that are coming out of your presentation about participatory assessments and this need to really integrate in the whole process the target groups themselves, and not only catalyzing adoption but monitoring it too. And that's a really really critical point to see the longevity of these approaches, and that's something we can hopefully raise more discussion on, perhaps in the panelist discussion. We can move on now. Thank you again, Emily. We can move on now to Samira Mohammed from IITA. You're very welcome, Samira, and you will talk to us today about can nature-based solutions support better plant health in climate smart ways. And your main focus is biological control of both native and invasive pests in Africa. And of course, pest invasion under climate change is one of the key threats that is emerging. So great to hear from you today, Samira, about biological control, in particular, how to tackle this challenge. Welcome.
Thanks for the invitation. Hi, everybody. As Paul said, I'm going to talk about biological control and how it's affected by climate change. Next. Okay, as my colleague from IITA mentioned, Africa has been and continue to be very vulnerable to invasion by various pests, whether it's weed or insect pests, all kinds of pests. And here I'm just giving an example of fruit flies and tuta absoluta. Those pests, since their invasion, they cause enormous crop losses, impacting on the livelihood of already poor resource farmers. But at ECB, we have developed a comprehensive, holistic package addressing those two pests. But here, I am going to, next please, I'm going to zero on the use of biological control. we have introduced, next, we have introduced a co-evolved natural parasitoid for these two pests from their aboriginal home. And we have tested them, as you are going to see in the subsequent slide. Next. But before that, we have to evaluate of what we have, whether they will be able to suppress this particular fruit flies. This in case for Bacteroceras dorsalis. Of course, we have our own native fruit flies. Those mostly the Ceratitis species. We have another invasive fruit fly, that's the Codecas cucurbitae, which is formerly known Bacteroceras cucurbitae, and we have the invasive one Bacteroceras dorsalis. So when we tested our indigenous parasitoid, none of them were able to successfully attack the invasive one, while they have done very those native parasitoid, they are be able to parasite our native fruit fly species. Now, the only choice we have is to look for a co-evolved natural enemy. Next, please. So we have introduced two parasitoid, and a parasitoid that is Phobia saricenus, and larval parasitoid that's like Smorpholongocoidata. And luckily, both of them, they have performed very well, except, especially Phobia saricenus in the lab. It yielded more than 70% parasitism. And based on their their performance, we are able to release them in several African countries, as you can see from the next slide. Next. Next, please. As for Tuta absoluta, this pest was first reported in East Africa in 2014, and in fact, from the time it was reported from North Africa till the time it almost covered the entire country, it did not even take 2 to 3 years. So as we speak now, Tuta absoluta, it found across the continent, causing massive yield losses. And what also contribute to this massive yield loss is the lack of the efficient natural enemy. And for that, we brought parasitoid from Peru. And in fact, this represents the first classical biological control ever to be undertaken against Tuta absoluta. The parasitoid turned out to be very effective. Again, under laboratory condition, it causes almost 74% parasitism. But of course, these are all in the field. We need to find out what's going for this parasitoid. We need to establish what is their performance in the field. So for this, next please. For this, the fruit fly species, we have released them across Africa. Some of them jointly with IITA, and other releases were done within different initiatives. But so far, we can almost say we have covered the different region of Africa, and Africa covered with the parasitoid release of fruit fly. But as for Tuta absoluta, we have only released in Kenya, Ethiopia, and Uganda. Next, please. But releasing them is something, but how they will be impacted upon by climate change, that's something need to be looked at. And of course, climate change affect the parasitoid or biological control at different level. Next, please. So there is a direct effect on and this one is, I'm not seeing well, but anyway, it affects the fitness in terms of the fecundity and in terms of reproductive success as well as the longevity. And if these are negatively impacted upon, certainly the natural enemy will not be effective. And also they can affect the dispersal, the parasitism, and it also affects the number of generations per year. Then, of course, there is an effect of the intra and interspecies competition. This effect can be either way, depend on the type of the parasite. Some of them they might benefit from climate change, others might be adversely affected, and most largely would be adversely affected. But there is other type of effect that is through hospital. Next, please. And
sorry, Samir, we're having a little bit of trouble to hear your mic. I don't know if you could move somewhat closer, and I think maybe it's about a minute or so left.
Okay, and now am I clear now?
That's good, thank you.
Clear now? Okay, the other effect is through host plant, that is basically through the disorganization of the host and the parasitoid. And there are also other effects of the expansion of host range of the parasitoid or expansion of the host plant shift. Next, please. Then, of course, there is a direct effect on host plant, effect on the phenology of the plant, and also effect of the structure, physical structure of the plant. There are, if the plant has trichome or and then it will affect the searching of the host. Next, please. And of course, there is the effect through the interaction of the host and the plant, and also there is the third level of the effect of, next please, effect through the interaction between the parasitoid, the host, and the plant. Next, please. Here we just I give an example of how the temperature will affect the establishment of parasitoid. And in this case, I have two scenarios. It can increase the area of suitability of the establishment. Here, for the first one is for Phobia saricinus. You can see for the current it is more of the around the equator, but in 2050, that with a potential increase of 2 degrees centigrade, the area of the establishment would have increased. And it's the same for small data. Next, please. But in case of the total parasitoid, the increase in temperature, the parasitoid will be at the suitable area will be adversely affected. But now, what do we do about this climate change to be able to cope with the climate change? Of course, we require agroecological based approach. Next, please. And one of the approach which Emily talked about a lot is the bush bull. With an additional one is agroforestry. I don't need to elaborate on the bush bull. All what I need to add to what she said, this is a co-design or co-implemented with the farmers, with all the benefits, the holistic benefits to the ecosystem, to the soil benefit. It covers everything, and it is climate resilient. And now also are exploring the bush bull for vegetable, including tomato and cucurbita. With that, I would like to thank the donor who are supporting ECB, and thanks to all of you. I hope I have not exceeded the time.
Thank you very much, Samira. And one of the nice things, one of the novel things we're seeing from your work there is that you're also tracking or forecasting the future distribution of parasitoid species and biological control potential. And that's really great to see, because while we're doing efforts to actually predict future pest movements, largely insect pests and others, it's somewhat neglected today to see that done for the beneficial species as well, because we really need to see that these services are maintained into the future. So thank you very much for highlighting that relevant work. We have scheduled some interactive element in the program. We have the Padlet open, so I could ask Agnes, she could share the link for us one more time in the chat, and you're welcome to go in there. I think you're very busy listening to the talks at the moment, so I think what we will do is keep this Padlet open for some time after the webinar today, and you're welcome to go in your own time and answer those questions. But Manu, would you like to quickly summarize what type of questions we have there?
Actually, not much, as you can see on your own dashboard. So in terms of the first question, nature-based solutions, we had one entry, agroforestry, agroecology, and then another entry with regard to biopesticides, biocontrol, and host plant resistance. Then in terms of awareness of climate-informed services for decision-making in plant health, there is only one entry here, and this not much. How familiar are you with the concept of One Health? There has been one interesting entry about Linnaeus as the creator of the binomial nomenclature for plants. It's quite a long one, but it links very well the kind of the human health with the One Health. And then yeah, then about food safety, only one entry actually, and this absolute yes. Policy needs, so far I don't see any entries. And then do you feel more dialogue, events, and so on? And I think that's yes. That's yes, but also with groups and which are not represented here. I suspect maybe the private sector, for instance, and farmer organizations. I'm not sure how many of them are present today. So this is all I can say in a nutshell.
Thank you, Manu, for summarizing what we've got so far. As I said, we will leave that Padlet board open, and we'll probably invite you for more further input at another time after the webinar. So let's move on. I think we now will move to the practitioner focused talks, and we had UBAC GC lined up. Unfortunately, UBAC had some emergency programs to deal with, so could not join us in the end today, but he did take the liberty to record his talk for us, so we're grateful to still receive input from UBAC through this presentation. So we have Agnes operating this, we have Anna Clara operating the slides, and we listen as we go through to the messages that UBAC has recorded for us. And just to note, he is the Executive Secretary of the FAO Regional Office for Asia and Pacific for the Plant Protection Commission. So a very relevant voice to hear in terms of dealing with pest issues under climate change and the need for regional cooperation. And his focus in the talk is on the invasive spread of fall armyworm. So let's have a listen to UBAC.
Very good morning and good afternoon, everyone. I am Yubak GC, working as a Senior Plant Protection Officer, FAO Regional Office, Bangkok. And this morning I am going to give a talk on the outlook on plant protection in general and fall armyworm control in Asia and the Pacific region. In my presentation, I will be highlighting some of the major actions in Nepal. Let me start my first slide. In my first slide, I will be explaining a little bit about the transboundary plant pest and their invasion in the Asia Pacific region. There are two major pests, fall armyworm, Spodoptera frugiperda, and desert locust at this time as a major transboundary pest. If we look the history of fall armyworm invasion in Asia Pacific region, in the year 2018 it invaded for the first time in India. Then in South Asia it moved to Nepal in 2019. Then it invaded almost all the countries in South Asia until 2020. Then we can see its movement and the invasion in Southeast Asia until 2021. Similarly, it reached to Northeast Asia. Fortunately, in Northeast Asia it has not been invaded yet in Mongolia, but it did not rest. It took its march continuously and has been reached even Australia and Solomon Island in 2021. Very recently its occurrence has been reported from Solomon Island and the neighboring countries in Fiji and Vanuatu. And if we look the history of its incursion, maybe outbreak, mainly 3-4 factors such as climate change, the impact of climate change, our agriculture practices, the agricultural intensification, environmental degradation, and in-country trade, they are mainly responsible for the exacerbation of this pest. And across the Southeast Asia, the invasion of pest inflict agricultural losses around 30 billion US dollar per year, and the monetary assessment has not been properly reported from all the countries, but the scale of monetary losses can be expected a huge amount, since it uh, caused losses in major cereals like maize, and it has wider host range. If we look back, the management aspect in the Asia Pacific region, mainly the chemical pesticides, is found one of the primary choice among the farmers. It is because the core IPM principles and decision criteria are rapidly abandoning, and these practices have led to an increased adoption of prophylactic measures like chemical pesticides. And research, farmer education, and country level policies are inadequate to promote non-chemical alternatives. Similarly, the agroecological practices are systematically overlooked as a result of the hurdle of the registration of biopesticides, new compounds, novel compounds. They prevent the availability because of this reason, and there are very hesitance in the uptake of biopesticides, so policy level interventions are also required in that aspect. Let me start about the understanding of fall armium and its management practices in the Asia Pacific region. Uh, Mainly, FAO regional office is working with the government counterparts in the region, and the ministries, related departments, the directorates, and agricultural offices. We conducted desk study, as well as we also had consultation among the fall armium focal person representing from different ministries. And also we undertook some of the ongoing fall armium mitigation efforts in the region. Mainly we conducted two surveys. Number one was related to about eagle eye view on Asia Pacific plant protection, and the survey 2 relates to filling the pulses of countries fall armium mitigation program. Through this slide, I am trying to give the farmers management behavior. If we see into the graph, almost all the countries, the farmers, they are emphasizing the chemical pesticide as a central pillar. However, at the same time, they are invariably considering the IPM. They are mentioning that key obstacles to adoption of the IPM are insufficient knowledge, inputs available, and some cumbersome process in the policies, in the registration of biopesticides. And at the same time, they also mentioned that there are IPM outputs and some of the good knowledge and technologies, but they are still immature, which needs to be fine-tuned and studied furthermore in a well-designed and a comprehensive farmer education schemes, including experimental learning. If we see here in the graph, we can see almost all the countries, the pesticide overuse supersedes the farmer management practice. Okay, let me start about the policy and legislation in the countries. Among the surveyed countries, 67% they mentioned that they have national IPM policy, including Nepal. In Nepal, there was national IPM program financially supported by the Norwegian government, where FAO country office in Nepal and the Ministry of Agriculture led by Plant Protection Directorate, they undertook this program, and the pesticide rules and the regulations are also there. There are biopesticide working guidelines in general. However, the invasive pest specific guidelines are not available in most of the countries, including Nepal. If we see the legislative environment, this favors mostly the chemical control. Why? The reason is mostly normally almost all the countries, at least 3 to 4 new active ingredients or compounds are being registered in each countries. And at the same time, there are multiple key deficiencies at the economic threshold level, ETLS, consideration of EIL, economic injury level, and promotion of biopesticides. So there are soft and hard policies to create further momentum for non-chemical control to avoid registration hurdles. Through this slide, I am going to present a good information that with the joint effort of the government, concerned stakeholders and FAO, actually we have a reduction in fall armyworm infestation over the years since 2019 to 2021. This situation was evident in India, Vietnam, and also there was a similar scenario in Philippines. However, I'm sorry that I could not include the slides here. And if we see the main reason behind this, the joint effort of the government represented by the fall armyworm focal person, mostly from the higher level people. In Nepal also we have representation up to from joint secretary to provincial level up to local level. So this is what that we wanted in other country as well. And future thrust for the reduction of fall armyworm needs to be emphasized on the host plant resistance. We have to check whether there could be some tolerant or resistant varieties, and similarly the biological control agents should be promoted in an inoculative and inundative approach, and a continuous supports in the implementation of phytosanitary and biosecurity measures needs to be enhanced in the policy level, since this pest is a transboundary pest and transboundary efforts are imperative for its reduction.
I think we can, this is the last slide that was provided to us by UBAC, and it summarizes different synthetic pesticides and their risk in terms of One Health context. But in the interest of time, I think we could skip past the final slide from UBAC there and just welcome Irish, our next speaker, Irish Bangwalat. Also coming from an Asian perspective, from the Asian Farmers Association for Sustainable Rural Development. And Irish, we're very grateful to hear your reflections on this idea of climate smart IPM and what it means from a practitioner's view to be able to implement these kind of practices. Welcome, Irish.
Yes, thank you, Paul, and thank you to the organizers for inviting the Asian Farmers Association for Sustainable Rural Development, or AFA. So again, good morning, good afternoon, and good evening, everyone. Greetings from the Philippines. So I'm here on behalf of AFA, which stands for Asian Farmers Association for Sustainable Rural Development. The next slide, please. AFA, before I proceed and share the work that we do as a regional network or an alliance of national farmers organization, the slide that you can see are the countries where AFA has members. All in all, AFA has 20 member organizations in 16 countries with around 13 million small-scale men producers engaged in crops, livestock, fisheries, forestry, herding, and pastoralism. And further, we collaborate with other farmers organizations in the region, in the Pacific as well, and also with other civil society organizations working with farmer groups, reaching around 30 million farmers in additional 12 countries in Asia Pacific. And I am very delighted to be here and share with you AFA's experiences and maybe some recommendations in response to some of the questions that and challenges that were faced by the different projects, as I was hearing earlier. So in slide 3, as you can see, AFA as a regional network of farmers organization has identified specific areas, 6 areas as a basis of unity. And one of that is sustainable agriculture. And AFA has been promoting organic agriculture practices, integrated and diversified farming systems, and more recently, agroecology as one of our solutions to address our challenges and to increase our income, and at the same time, be able to produce more food in a safe way for our communities, families, and localities. And within this agenda, AFA has promoted specific practices, and one of which is the integrated pest management, which is embedded in the systems or in the set of practices that I have mentioned earlier. I also want to mention that AFA members are mostly smallholder farmers, and AFA work with many partners, NGO partners, and also government agencies, and through the training, through the capacity development programs that we have been receiving, we have learned about the link of plant health, soil health, to the health of our farm, to our health. And based on our experience with all the training, with all the implementation that has been done, we can say that transitioning from purely chemical agriculture to agroecological agriculture is not easy. It's a hand-holding process between farmers and support organizations such as NGOs, CSOs, research agencies, donors, and other value chain actors. In slide 4, in a more specific manner, we have been, the next slide, we have been promoting farm diversification. Of course, sorry, can you go back to the previous slide? Yes, thank you. Of course, there is no single solution. But there are different techniques in sustainable farming that can make farmers less vulnerable to shocks and losses. And farm diversification also provides resilience by lowering farmers' costs, investments in seeds, fertilizers, agrochemicals, pesticides, and it does increase their income. So the farm that you see there is in the southern Philippines. So we did some documentation of this integrated farm, and we were able to document the change in income. But of course, this is done as a case study and not really in a sophisticated way of impact evaluation. And with ecological farm or agroecological farms, not only that, the farmers are able to address pest problems, but they also they are able to nourish their soils, and this has many outcomes, and in a more practical way, it does translate to income increase and less borrowing from the side, less loans from the traders, agri-traders on the side of the farmers, and this helps them sustain this way of farming. The next slide, that is an example. It's a duck rice system. Again, it's what we have promoted as part of our agenda. It's a rice duck system, and this is still being practiced in the Philippines, and also it is being practiced by AFA members in Vietnam. And there are, we know that there are already documentation on, on the positive outcomes of this system, how the movement of the ducks actually help the tillers to produce more, and how the manure of the ducks are being used as fertilizer, and how the ducks eat harmful pests, most especially the snails and the weeds. So we are happy to know during our learning event last year that this is still being practiced by many of the AFAM members. And then
Irish, it's maybe one minute or so. So I don't know if
okay,
you have some slides. Yeah.
Yeah, thank you. Yeah, the next slide, you will see here the agroforestry system. It's very similar to what has already been discussed, but it is massively practiced in Laos and in Kyrgyzstan by our members. And then the next slide, I just want to emphasize that we also promote the use of forgotten food or the neglected, underutilized crops because they are less they require less inputs, they are hardy and more tolerant to pests. And we are into a collective action where we are hoping that these crops will actually we will develop value chains from these crops so that farmers will continue to cultivate them. And then the next slide is, yeah, that's our members in Indonesia and Indonesia. So this farmer Pak Jo, he is a seed breeder. He successfully developed a variety of rice that is more tolerant to pests and diseases. And it took it's not a short period of time, but it's a process. But this is one way to be able to scale up some initiatives. So work with farmers, work with master trainers in India to scale up such innovation. And then the next slide, yeah, it's another approach. That is in Laos to develop innovation that farmers can sustain and control. And then, yeah, the next slide, another approach, farmer to farmer exchange. And the last slide I wanted to highlight as I close is the value chain approach. So as mentioned, we from production to market, we support our farmers to ensure sustainability of what we do. So I would encourage projects to work with farmers cooperative, farmers organization. They can support you in the extension services. It's also through the cooperatives, farmers cooperatives and agricultural cooperatives that products that are produced in an agroecological manner can reach the market. So I will end with that. And yeah, if you're interested to know more about AFA's work, you can reach out to me. I can type in my email address. Thank you. And sorry for the extended time.
Thank you so much, Irish, and we really appreciate your contribution there to share from the farmer's perspective how we can work with these types of initiatives, habitat diversification, diversifying farming systems. We really do need to understand how these actions are implemented on a practical basis with the farmers. We can move on now to the last speaker, Benoit Granlofin, and joining us from ECOWAS and a range of other organizations affiliated to quite a few. And Benoit, I would like to invite you to give your presentation on prevention, monitoring, and control of desert locusts with a focus on West Africa. Just to note the time, we will run a bit over for the panelist discussion, but Benoit, welcome here at least for your presentation.
Thank you, Paul. I hope you can hear me very well. Please confirm if you can hear me.
Yeah, sounds good.
Yeah, okay. Yeah, because of the low connectivity, I would stop my video with your permission. And then, dear colleague, thank you so much for this opportunity. I just want to share the regional perspective and by implementing policies and also providing capacity building actions to the communities and then to countries in managing and then preventing and monitoring, also to control desert locusts in West Africa and the Sahel. Next slide, please. I must say that in this context, we need to remind ourselves that we have key elements when we are talking about the climate smart, climate change, and then also plant health. So probably you may know of this, but it's good to remind us to put it in a context that increase generation, climate change, also seasonal phenology of pest hosts, timing of the emergence, and then also it increase occurrence of lethal temperature for the pests, and then that give them more opportunity to multiply very fast. Increase also pest damage and pest risk, which is very important, and then also it also increases geographical range. And then we have seen that in the past, looking at the fall armyworm, how it has been distributed across continent, and then also desert locusts in this case. So there is a need to incorporate climate change in the pest risk analysis, adjust plant pest surveillance and monitoring, increase information exchange between countries on pest occurrence, interception, and then also trade flows. Because remember, interceptions are coming in play, especially when it comes to the application and then implementation of WTO SPS agreement, which countries has already validated within the WTO as far as international trade is concerned. Also, we also need, in this context, conduct research on climate change and pests, which is this forum is a very good platform. Increase international cooperation on plant pest management and climate change, and then also increase capacity building. And then I think this forum is the well placed place where we can share all those and then promote international cooperation in this area. Next, please. Now, with that, you may recall that we have now some invasion of desert locusts in the eastern part of Africa. I want to name Kenya, Somalia, and Eritrea in the eastern part. And then with the prediction of FAO, we have that alert. And then we have taken some steps in our region to prevent that it comes to us here. So with that alert, it was an alert of the invasion risk. And then with that alert, we have conducted some scenarios to see in which scenarios we will be having the invasion. And then also we have conducted some ex-ante impact assessment to see what are the benefits, and then what are also the other aspects that may not be seen earlier. And then also we have conducted some appeal and advocacy. And then most of these have been presented at the ministries, because we do believe that at that level also we need political support, and then also some donor agencies. Next. Now, next, please. Now, yes, just click one more again, or two more. Then we'll have all the, again, click again. One more, please. So you see this map, just give us no, go back, please. So previous slide, sorry. Yeah, so this one give us now the early warning system in West Africa as far as this locusts is concerned. That is the prediction we received from our colleague from the FAO office. And then you see that here, you see the eastern part of the region, and then that is where desert locusts occur in last month of 2019 through 2020. And then also 2021. Then we see that prediction give us an alert that the invasion will come through West Africa, through Sudan, and then also Chad, and Niger, Cameroon, Nigeria, and Mali, Mauritania will be the most affected countries in our region. So we have now, that's what I was saying, conducted an economic model to develop, to really project and then see what are the impact. And remember that with all these very cocktail of risk, now we have more than in our region, more than 70 million people who are already food insecure in our region. And we at the FAO with the ECOWAS Commission, we launched this appeal to the member states and then to the head of state so that they will come in and that appeal has helped us now to really reduce the risk. And as we speak now, I will tell more about the next in the next slide. Please, next slide. So with that appeal, we conducted the different scenarios. These are the two scenarios. So one, we look at what are the first line countries, and then that we call them frontline countries. And then also the second scenario is the invasive countries. So in the first line countries, there are 6 countries, and then we have provided more support through the appeal. And then again, this scenario 2, the scenario 2 is more the invasive countries. And then there are 4 countries there where next, please click one more. Yeah, and then you could see from this map that all those countries are in that line. And yeah, please click again. And this scenario have helped us now to contribute to the FAO strategy. Please, next, to the FAO strategy, which is to prevent by having anticipatory strategies. And then if you click one more, you will see that it has helped to contribute to the objective to prevent the development of fully fledged desert locusts, and is contribute to the no regret investment. Because people think that when you are investing, even if you don't have the pest, is a waste of resources. In this case, I could tell you that is a no. The answer to that question is no, because it helps to prepare and then to anticipate some of the action or some of the, and then to safeguard really the livelihood of the population. Next. Please, next. Yeah, so in this appeal, we have 3 components: curb the invasion of desert locusts, and then our investment has contributed, it takes 76% of the investment, and then safeguard the livelihood of the population, that and then help them to recover quickly, and have taken 4%, and then we have regional coordination preparation action, which have taken 20%. Next slide, please.
Benoit, may I ask, just in the interest of time, could we go towards the recommendations, do you think?
Yeah, it's because of the, yes, I'm now going, but before that, in the front line, you see that we have now strengthened the capacity of those countries, of the frontline countries, as well as, next slide, please. Yeah. So we have conducted some aerial survey using helicopters, and then also some prospection, and we are also posted some pesticides in those front countries, namely Chad and Niger. So in case of the invasion, they are well prepared to really go into action. Next slide, please. Please. Yeah, and then we are conducting also ground surveillance in Mauritania, Mali, Niger, and Chad, and then also conducted training on prospection techniques, use of and management of pesticides, because pesticides is most used here, and then to safeguard the environment, and also training on data collection and data analysis, and also interpretation. Next. Yeah, also we have introduced the drones to be able to conduct prospections, especially when we see human insecurity in our region here, and then there are some areas that cannot be assessed. So with the drones, we believe that we could be able to collect those data and then be able to conduct proper surveillance, and then also data analysis in this region using the drones. Next. Yeah, in the invasive countries, these are the 4 countries. So we also prepare them to be able, so that they will be able to also to have a same understanding and then be prepared in case of invasion in our region. Next, please. So we conducted advocacy within the ministries, and before the advocacy, we conducted this technical training. And then at national level in the 4 countries, we have now a light staff which are well prepared they have the information, they have all the tools, yeah, to be able to act quickly when the desert locust is here. Next. Yeah, high-level advocacy as well. And then the ministries of agriculture of all those countries are well informed, and then they have made commitment to really contribute from the national budget to be able to tackle the issue. Next. Next, please. Yeah, now currently, as we speak, the situation in this region is very calm, and then there's no alert for really panic. But the most important thing to note is that we really need to be alert, and then we must be prepared. And then in a case we have a desert locust, then we should be able to act quickly, because that is the way we believe that anticipatory action is the way to go. We do not need to really have already act when the pest is here. Next. And then the next slide is my final slide. And then these are the more important slides, putting all these together. We really need to continue carrying awareness and advocacy, and also mobilize more resources, especially to operate. And then also we need to operationalize the use of the drone for all the countries, as well as having capacity, strong capacity at national level to prevent, and then also to protect, and then also be able to collect data, and then monitoring and have strong control system at national level. And again, is really the time now to operationalize some of the decision tools, because out there we have a lot of decision tools which are not implemented at national level. So those decision tools must be now, this is the time to implement them. And finally, but not least, within this region, within the West and the Sahel region, we have established a national plant protection organization and partners task force. And then that task force is really functional. And now we are now in the process of requesting the International Plant Protection Convention to really grant this region the status of regional plant protection organization, because we believe that once we have that status within this region, we will be able to tackle and then really operate some of this action together with our partners within the region. With that, I really thank you for your attention. Over.
Thank you so much, Benoit, for that. Really interesting to, in particular, see some of the technology advances you're bringing up with drones for surveillance, and also to hear the needs that are there for advocacy too. So there really is a political component to this, to cooperate across borders, because of course, tackling issues like those invasive pests, it really takes cooperation. They don't respect the borders, and so we must oblige to collaborate and cooperate across political boundaries. So thank you for sticking with us. We're running a bit over time, but what I would like to do now is to invite our 3 panelists. It was Irish, Emily, and also Titileo. So we'll bring you back into the spotlight here in the webinar. And what I would like you to do, you've been really good to address the questions as they've been coming up in the Q&A. I noticed there was some on gene transfer between for aflatoxin related genes. Titileo, that was really interesting to see your response. And there has been a question to Emily too on the mechanisms that underlie push-pull systems and the relative role of volatiles were assumed to be largely behind the mechanisms that support these systems, but we see that there could be other traits involved too. So thanks for addressing those questions. We could see in the Q&A as they came along, but just to help close the webinar now, I think was wondering about your thoughts about the ways forward for implementing, as we say, climate smart IPM, and I've given you the task to concisely summarize what you think are the most important ways forward to implement climate smart ways of plant health for smallholders. So I think we could start with you, Titile. How do you see the way forward?
I thank you, Paul. Some of the speakers have spoken about this, and there is need for interdisciplinary efforts to be combined and done in a way that the stakeholders are involved. So participatory involvement of the stakeholders, and ensuring that this knowledge does not stay at the science level or at the policy level, but that everyone is working together to bring these technologies to the fore and to use. And that's one thing I would say needs to be done more, highlighted more as with respect to One Health and bringing focus on plant health. Yeah, thank you.
Yeah, thank you, and good to be seeing the work that you're doing to bring plant health really into this framework of One Health, as we've seen today. I think that's one of the key messages from the webinar. Irish, I could invite your reflections.
Yes, thank you, Paul, and thank you to all the speakers. It's been a very informative discussion so far, and I can say that there's so much scientific knowledge that has been produced, and at the same time, there is also the indigenous knowledge that is also valid. And I think it's really bridging these two sets of knowledge to be able to address challenges that farmers are facing on a daily basis, and also emerging challenges given the changing climate, and in particular of course in the context of pests and and disease management. And also lastly, to bring the innovations to scale from a project level or from pilot level. Our call as a farmers organization, AFA is part of a farmers forum at the regional level and also at the global level. And we always say to partners, work with farmer groups, work with farmers organizations, work with farmers cooperative, because this will help sustain initiatives and bring this to scale and bring this to the farmers' fields.
Yeah.
Thank you.
Thank you, Irish. Yeah, indeed. I mean, scale is one of the key words there that I would pick up. And we don't have a choice. If we want to do these things, it needs to be co-created, like you said, and have the farmers at the central place of the knowledge. And then Emily, to help us close the webinar today, your reflections on the way forward.
Thank you, Paul, and thank you, everyone. This was super interesting today to hear also these take-home messages that you've just said. I completely agree with these also, that the farmers are at the center of this, and definitely co-design, co-creation of all of this is indispensable. But I also believe that there really need to be very clear, very strong, decisive incentives at governmental levels. These have to even the path, make it easy for the innovations to be adopted and to come into the market. And overall, I think my take-home message here is that we need to mainstream these sustainable technological innovations. They can't be on the fringe. They have to be the major way that farmers are being advised to produce. And this also will go through priority training for extension services. It will go through economic incentives, tax directives, for encouragement of different value chains. And I think that that is a major mechanism by which it will happen. So it's very, very much through the government and policy level, in addition to the farmer and multi-stakeholder base.
Thank you so much, Emily, and to the Leon Irish, and indeed to all the speakers today. I'm grateful that you've been responding in the chat to the questions as they've come in, and also sharing some input on the Padlet board, which we will take further in summarizing the outcomes of the discussions that we've had today. So really, I just want to give a thank you to you all today, and thanks for sticking with us with the time overrunning. We had, it's so hard to, you know, the enthusiasm is pretty great, and we will produce some outputs based on the input we've had today. And I think both on the science end of the nature-based solutions, and also incorporating the practitioners' views too, that we can really get climate smart ways of IPM working that are going to help smallholder farmers keep food security, keep food safety under climate change. And that's the key message, I think, from the report, from the talks that we've had today. So thank you once again, and keep an eye. We can have some further outputs in the future, and the video recording for those that missed or want to recap on the slides, that will be available in due course. So thank you to all the speakers, all the organizers, and indeed to you, the participants, for your input and questions, and for making it a stimulating webinar. Have a good rest of your day, and thanks once again.
Thank you.